Hello everyone, myself Arun Shambhu. I'll be the host for the day. And firstly, I thank each of you for joining this webinar titled From Blueprint to Digital Model. Today, every industry is adopting digital in its own way and simplifying their delivery pipeline. Our construction industry is no different. We have been actively experimenting the new advancements in the information technology from time to time, and we have been adopting it in our own way that suits best to our industry. So through today's session, we have Mr. Dr. Simon Jayasingh, who will be kind of taking us through a small journey of how the technology has evolved in our construction industry. To give a quick intro of Dr. Simon. So Dr. Simon is an young entrepreneur who is driving the digital transformation and open BIM. He has his own venture by name Yatzer Creations. And through this, he has been actively providing consultation and is building his own marketplace, and is also kind of into the professional learning help, wherein he's kind of creating a lot of new ways and means to help people learn from the industry. So in a way, Simon is kind of bringing together the R&D, academia, and industry to help our industry adopt the digital in a way that suits for us, and also adopt the open BIM as it is being kind of adopted across the world. With this, I will welcome Dr. Simon to share his insights for the next 30 minutes. Over to you, Simon.
Thank you very much, Arun, for the introduction. I'll share my screen, and please let me know if my screen is visible.
Yes, it is visible.
Yeah. So thank you. Once again, I welcome you all. The topic for today is BIM 101, from blueprint to digital model. So when we talk about building or infrastructure project, we often picture the physical structure, a wall, a column, a beam, etc. But long before anything is built, every project starts with a blueprint, a drawing, an idea captured on a paper. So in early days, this paper like blueprint was the main language of construction. So then came the digital age where we still produce, the drawings, but without data. That's where BIM changed everything. So it allowed stakeholders to work on the same digital foundation. So the same model can connect with schedules, budgets, even live data from sensors after construction. So it means one model can serve the architect to design it, the engineer to build it, the facility managers to maintain it. So all using the same accurate information. So this journey from the blueprint to digital model, it's not just about the technology, but it is also about how we create, how we share, how we trust the information across the entire life cycle of the building. So on this regard, we will answer a few questions. So why and how BIM emerged? So to talk about this, it all started in 1970s, where computers were still the size of small rooms, and architects were using pencils, rulers, and tracing papers, etc. So a few pioneers, they began experimenting on how a computer could represent a building, not just as a drawing, but also as a collection of objects like wall, door, windows, that knew what they can know what they were. And early work they call the building description system. This actually planted the seed for how what we call now as BIM. So through 1980s, the first software tools they appeared, and they allowed designers to create 3D models that can be viewed at different angles, and also update some changes. And it was a huge leap for something from a blueprint to a digital geometry. So by 1990s, the concept of building modeling became recognized in academic and professional discussions. So researchers they began talking about the multi-view models. So meaning that one source of information could produce multiple views, different views. So structural, architectural, mechanical, this without redrawing anything or everything. So this was the real beginning of the digital coordination between different stakeholders, different teams. So, but it's important to remember that during this stage, computers were still expensive and very slow, and data sharing was very limited also. So even though the technology existed, only a few advanced firms and universities were experimenting on them. So then by early 2000s, the world of design and construction they began to change in a visible way. Like computers had become faster, softwares was easier to access, and the idea of a building information model they started gaining attention. So this was when BIM truly entered the mainstream professional use. So companies began promoting the term called BIM, and people started to realize it wasn't just about making the 3D drawings, but it also is all about creating a single and a coordinated model, so everyone can be involved in the project. So for instance, when an architect changes a window size, the structural engineer could instantly see how it is being affected with a beam that is above the window. And then a quantity surveyor can, could also do a quick cost differences. So that was a level of coordination that was there. But uh, at this decade, they also saw a major shift in terms of mindset, say from drawing buildings to managing building information and things. So by end of 2000s, BIM had moved from being an experiment in advanced firms, and it became an industrial expectation. So next, as BIM gained momentum across the industries, so the in 2010s, it became the decade of standardization. So different countries and organizations started realizing that while everyone is using BIM, not everyone is using in the same way. So a project in one country might call an element as slab, while another call the same thing as floor plate. So these small differences they created big coordination problems, especially on a global projects. So to solve this, the international frameworks like ISO 19650 were introduced, and buildingSMART they were all introduced, and these they define BIM as a shared digital process for managing information throughout the design or the construction and operations. For example, a project could now have a defined common data environment where design files, schedules, approvals, they all follow a consistent formatting. And no matter like who joined when, but it can be a new consultant or a new contractor. So the data remained readable and also traceable. So the technology also matured during this period, like cloud-based collaboration became very normal. That allowed teams from different cities or different time zones. They work together on a single model in real time, and digital approvals or version controls and automated model checkings they all replaced all the manual way of working. So by today BIM is not a niche innovation. It's not new. It's a regulated process and a foundation for decision making. So standardization has turned BIM into a common language in this era. And moving on with the emerging directions, today we are moving further talking about intelligence, connectivity, and real-time decision making. So the buildings buildings we design are becoming a part of large digital ecosystem. So for example, sensors in a smart office can now feed the live data into the same model that was used during the design. So if the air quality in a room drops, the system doesn't just trigger an alert. It knows which space it is and how the ventilation system is connected, and can even also suggest an adjustment automatically. So that's the power of connecting BIM with IoTs, and creating what we now call it as the digital twin. So it's a living version of building that continues to learn and then also respond. So artificial intelligence, machine learning, they're also reshaping how we work. So designers, they use AI assisted tools to explore multiple layouts, their options in just minutes, and options that took weeks, to test manually. They just take only minutes right now. And contractors, they used to predict models to forecast any delays or cost overruns before they could happen. While also the facility managers also can rely on automated insights for maintaining the assets. And another direction is that BIM meeting GIS. So this is extending digital models to the entire cities, like urban digital twins. So this helps the planners to simulate the traffic flow, flood risk, energy use, connecting infrastructure and buildings into one integrated system and something. And also reality captures like drones, laser scannings, they've all made it easier to track the progress and also verify the construction against design in the real time, and so on. So we no longer wait for a site report, so we can just see what's happening live in the 3D with centimeter level of accuracy. So although these trends points to, so altogether, these trends, they point to one clear future, which is BIM is evolving into a dynamic intelligence ecosystem. So that is the one that connects design, construction, and operations in a continuous digital loop. So having dealt with why, so we will now move on to where BIM fits in our where BIM fits in our project or in our organization. So a typical team structure would look like, you have the leadership team, you have the managerial team, you have the technical team. So this is a hierarchy where each and every organization runs. So a leadership team will take into consideration the strategy. How do they formulate the strategy to organize their business and also their projects or also their assets. And whereas the project management or management team, they try to bring in the process, how to achieve the goals that has been set and as a strategy. And well, technical people like clients, consultants or the contractors, or any other stakeholders who are delivering the in delivering the project, they try to bring in the technical skills, the capabilities in order to fulfill the goals that has been set. So a typical team can look in these broader sense, and also in another broader sense, we can also streamline into governance level drivers, where we have governance, we have their own kind of requirements that they wanted to bring in this BIM into their solutions, into their processes. And we have organizations where they wanted to bring in the BIM to be deployed in their organization to align with the governance or to have better ROIs. And also the projects that bring in to the use cases of BIM to have better collaboration and understanding, to speed up the time and reduce the cost. And these are some of the the cases where the BIM can actually brought into a complete organization. So it's across the life cycle of any project where we talk about pre-construction or the construction or the facility management stage. This BIM is also applied into various sectors like like buildings, like airports, railways, harbors and docks, oil and gas. There are various sectors that can be applied. And not only that, it can be applied into even to different fields like greenfield projects or brownfield projects, which is the new constructions as in greenfield, and brownfield as the existing constructions to be constructed as a digital twin model. And also in the procurement processes, where we have the traditional procurement processes, these BIM can also be adopted in those procurement methodologies, and there are many new kind of methodologies where we try to bring in integrated digital delivery mechanisms, BIM alliancing, and there are various other methodologies, the procurement methodologies that we adopt in our workflows. And talking about people who are involved in this life cycle, in fact, we did see that there are various stakeholders who are there, but each project is unique, and each project has their own kind of stakeholders, own kind of processing, and therefore across the project lifecycle, a client sets the requirements, talking about what is the organizational requirement, and then bringing down into the project level requirements, making that at a project level requirements, and then a project consultant, they help these clients also to promote these requirements, and then bridge the gap between the requirements and the deliverables together. And consultants, special consultants, like for the fire and safety, for any designings, we bring in special consultants, we bring in contractors, manufacturers, suppliers, vendors. They're all into this life cycle on a particular project. So when BIM can be used, how BIM can be used by these people, like in their workflows. So moving on to their processes, once the process is set by the client, by the the consultant, design consultant, by the contractors, once their processes are set, then they can deploy their BIM into their workflows. For example, a consultant can perform a pilot project. So understanding how BIM can be applied into a particular use case, by a particular use case in a project, or a consultant or a contractor can do some mock-ups, do some maintenance drills. So these kinds of activities, they help also to upgrade our the level or the maturity of use of BIM in our processes. And towards the technology part, the technology is again whatever the the stakeholders are, whoever the stakeholders are, whatever the solutions that we already have in place. Like it can be project portfolio management, or it can be an ERP solutions. It can be a digital tool that we use for designing, or for costing, or for estimation of the resources planning, and or for project planning and scheduling, and for delivery mechanisms, for soft landings. It can be any kind of any stage, or it can be any kind of technology that they use for delivery of such outputs. So the technology part is also like, for example, robotics that is being used during construction stage, that can also be integrated into BIM, and the digital twin integrated into BIM, or the accounting solutions can be integrated into BIM. So the integration of this technology into BIM can also happen across the project lifecycle. Now, what enables this transformation? So firstly, we are bringing in few use cases where one is the cloud computing, because in recent times, we start to collaborate with the stakeholders on a complete cloud platform where a single model can be managed by different discipline stakeholders. Of course, there are restrictions, there are permission levels that have been granted, should be granted to stakeholders at different levels, permission levels. But the kind of the technology that we use today to collaborate using cloud computing is giving us an advantage of using the real-time modifications that are happening in our models. And virtual reality, this is for the visualization. It can be used for the clients or for the facility teams to understand, or for the construction teams to understand how the assets are being built and how the maintenance has to be done. And they use various technologies like virtual reality, augmented reality, or mixed reality. And each use case can contribute to understanding or the knowledge, visual knowledge of what is to be built or what is already built as an asset or as in a process. And we have drones and advanced devices where we use these drones to capture the data, and this can apply to even horizontal constructions or vertical constructions where we move with varying heights. So we have so many technologies to capture these data, and thereby these data can be integrated into BIM systems and solutions, and we can measure them very much accurately. And we have robotics where these robotics are being used in industries, which is offsite construction, where we try to build elements, components, or even buildings at the industry, and then we transport them to the site or the execution place where that asset has to be built. So these kinds of the working principles, the working methodologies using robotics are also they beautifully integrate with the BIM that we are talking about, with the models that we are talking about. And 3D printing. And this is for on-site construction where we wanted to have the technology adopted on site and reduce the time, reduce the labors, and increase the productivity, increase the quality. And these kinds of the technology on site can also be integrated with BIM, that enables BIM in a even more higher value. And not only those technologies that we use there, but also construction systems. We are now talking about the prefabricated buildings, which is off-site, fabricated in the industry and then brought into the site and assembled in the site. And we are talking about green buildings, which is more effective. We are talking about eco-friendly constructions where we use a lot of environmental friendly materials in order to construct. So these construction systems, and then it moves on to the management systems where we have lean construction, reducing much of waste. And as far as this lean construction and the reduction of waste is also concerned, I'd also like to point out that it is not only about the reduction of waste in the designing, planning, execution, and we try to talk about the reduction in the information waste that we also produce. So the lean construction comes under the lean construction where BIM helps us to manage these information properly, and so that we can reduce the waste even in terms of information. And common data environment. this becomes a place where all the stakeholders come together and access or share the files, have one single source of truth. And we also talk about the collaborative working environment where the collectively, there are multiple systems working together on a single platform. So these are management systems that enhances the technology. And artificial intelligence and machine learning, of course, this has become wider use, and nowadays, and the adoption of AI and ML has been very steep, and our industry is not, is not an exception. But there are a lot of use cases that has been adapting to use these artificial intelligence and machine learning in their workflows. And here is one example where we try to capture the data, and while processing it, we just delete all the green materials that we see around those construction place, and we delete them, and then bring out only the model and process only the model data what is required. So processing of data is also very important in these kinds of by use of these machine learning and artificial intelligence. And coming to the digital twin, of course, it is the physical and the digital virtual representation of the digital of the physical component. So the digital twin is the physical as well as the virtual component, both playing their parts, and both playing in both directions. So when there is a something that affects the physical, that is replicated in the virtual, and whenever something is affected in the virtual, it gets affected in the physical. So this is how a digital twin works. Of course, there are a lot of connected systems towards digital twins where we use IoTs, for fire, for building management systems, for securities, for quality management, for air quality management, for energy management, and for space plannings, for asset management, for space plannings, for occupants comfort. And there are multiple use cases surrounding these digital twins. So as we are talking about the model here, the models that we bring from the design phase to the facility management state, and this becomes a one source where we try to integrate it with multiple technologies on a single model. So this can also help us in predictive maintenance or real-time maintenance, or integrate AI, and also have a remote surveillance systems. So how this is managed and standardized. So bringing all together in a collective form, um, there are various working styles that has been differing now. The workflows, what we call workflows, are being called as process optimization in the future. So we are transitioning from workflows to a process optimization. We are transitioning from centralized working to a cloud-based collaboration. We are transitioning from predictive analysis to an automated resolution mechanism, and we are trying to talk about developing around a scenario to developing with the final goal in mind. And we talk about centralized IT to a cloud IT. We talk about paper electronic communication to a paperless documentation. We're talking about IT-driven workflows and moving to KPIs, but that becomes very much important for the checks, auditings, and we are talking about process and workflow training to a role-specific training in terms of capability building. And we're talking about technology-driven devices to human and technology co-working. So the mindset of us that we are currently in this BIM era, we are transitioning from here towards something working styles that are moving towards completely collaborating and co-working, and real-time working together. And and therefore bringing this complexity, it has a very big complex in nature, and therefore bringing people, process, and technology together, this is actually influencing the flow of information that is maintained across the project lifecycle. So there are two forms of exchanges that can happen in two models. One is asset information model, the other is project information model. There is a structured and an unstructured information, where structured information can talk about the graphical data and non-graphical data. Graphical meaning the length, breadth, height, and non-graphical data meaning the color, material type. All these can be structured, but there are others like unstructured data, which is document, where you have the warranty guarantee cards in terms of PDFs, or you have images, or you have videos. All these are unstructured form of information that we have. So these information, structured or unstructured, this needs to be maintained across a project or for the asset in itself. And therefore, there is importance of standardization of all these information across right now. That is required because we need to have the same kind of interpretation as we already discussed. A stair should be called as a stair, a floor should be called as a floor. And this standard is also important for us to automate the processes. So computers can understand a similar language. It cannot understand different languages. So we'll have to automate the processes. And the interpretation of computers should also be, in line with what we are developing. And this is also helping us to compare and learn as a deliverable, as in a workflow. And for these standardizations, again, open data is also very important. The open is because it is open, and it is interoperable between a lot of devices to understand and interpret in a similar language. And second, it is to have a consensus. It's not the single player who can actually define what is to be exchanged. It is about the consensus by many stakeholders. So that is that can help with open data, and also to control your digital destiny. So you're not locked into a single vendor, because your asset, whatever that you create, as in a model that has to be maintained across its lifespan, across the asset's lifespan, which is about 70 years or 100 years throughout your facility management stack. So when you're locked in with a particular vendor, and you're losing all of your data during your facilities time. So open data becomes very essential in those kinds of places. And this is the reason why the open BIM, there are open BIM enablers for us to enable mission to mission level of understanding, a mission to human level of understanding, a human to human level of understanding. So the interpretation of each and every collaboration, or each and every communication that is happening between systems, between missions, between people, between mission and a people, all these are being streamlined and standardized. And not going depth into it, but this the BuildingSMART has actually developed these kinds of open standards, open BIM standards that enable us to achieve these kinds of consistency in terms of information. So the key takeaway from this transitioning is that one is collaboration, the other one is intelligence. So as in a collaboration, we talk about an integrated systems where we collaborate with stakeholders, we collaborate with different design principles, we try to bring in different technologies and collaborate with them. But there is also a part where intelligence plays a part, and this intelligence has to be built on verifiable data, or a quality data. And this is where BIM comes into place, and open BIM comes into place, that can enable the future technologies like AI, machine learning, to adopt these the verified data, or to bring it to an intelligence level, and then combine collaboration and integration and intelligence together, calling it as co-intelligence, co-working. And thank you. Thank you for your listening. I think
Yeah, thanks, Simon.
fine. I think I'm on time.
Yeah, you are.
So
Thank
yeah,
you.
thank
So,
you.
firstly, thank you for sharing all this insightful preview into how the technology has evolved from last 2 decades and how it is going to take shape in the next decade. And all the insights you gave about the team structure, the workflows, how they have evolved, it was really good. And I feel that people attending the session today have definitely some insights that they can take it and adopt it at their end. So with that, I have some interesting questions, and I would like to just take you through the questions so that you can share your answers. So firstly, we have some questions on the chat. Let me take it from there. So we have a question asking what is your suggestions to the SMEs in the architecture and engineering services about the BIM implementation?
Um, yeah, we can take it in different levels because big technology firm who is very big and kind of size of the manpower or the technology, the adoption level depends on their maturity. And if it is a small scale, the adoption depends on their own maturity. But whenever we try to adopt any kind of BIM technologies or things, I would suggest that you start with a small use case. If there is a problem statement that you wanted to address, automate that first, and then move on with integrating systems around surrounding that. And this is where actually you can try to adopt the open BIM principles or the use of technology one by one as in a plug and play thing. Yeah.
Great. So the other question is if the construction industry still fundamentally demands traditional 2D drawings for contracts and execution, how can a team justify the deep investment and cultural shift required to build a data-rich process that drawings fail to represent?
Okay. My understanding is that how this transition can help in today's use. Am I correct? Um,
Yeah. So basically, the the question is like the industry is yet demanding 2D drawings for the
yeah,
contracts and
yeah,
execution. So if
yeah.
this is the way it goes, like how do we justify the investment that we are putting into all these data-rich processes?
Of course, I see a lot of mandates that are happening across global, where different countries are bringing in mandates, even for building permits and so on. And even in India, we are moving towards standardization and adopting a lot of technologies. In fact, it's not new for India because we have multiple platforms like Gati Shakti, smart cities missions, and so on. So these are all there for us to have different faster decision makings, and for better monitoring systems. So when we talk about these, we are not new even in India. So the drawings, while people are asking for drawings, but we are slowly transitioning towards completely digitalizing and with becoming paperless. And it is happening in a faster manner because many other countries also are adopting towards that lines. Yes.
Okay. So I have a few small questions that I have received through the Q&A. Like the first question is like, what is the next big thing or big disruption that we can expect in the construction?
So if you look at how construction industry has evolved, like even major shift came from technology, like making the decisions faster, and it is the information is clear. So the next disruption will also follow the same rule, but this time it will come from intelligence and collaboration, working together. So the major wave will come from integration across systems. So BIM connecting GIS, IoT, facility data, and so on. So it's the fusion of multiple technologies working together. So this will turn the construction from a reactive process into a predictive and a data-driven ecosystem.
Okay. So follow-up question on this, like when we are adopting digital tech, so should somebody adopt the entire end-to-end tech stack at one go, or should they try to plug and play whatever is required and play their role in the delivery? What is that the newcomer should actually adopt?
Yeah, as a same question, it depends on where you are in your journey and what you want to achieve. So if you are a large organization like with strong IT and stable processes, end to end is powerful, but it also depends on it also demands time, training, and significant investment. So you can't switch it overnight. So on the other hand, many companies like small and medium-sized companies, they all succeed using this plug and play approach where they start by digitalizing only the most critical pain points. Like a quantity surveyor might begin with an online estimation tool that links to the Excel sheets. So think of it like adding a piece of puzzles. So you don't need the entire picture at once, but you just need to do the right things, make the processes. So over time, so as your digital maturity grows, so these pieces can be connected through open data standards and shared format. So the key is here to contribute your part.
Great. So before we just wrap up the Q&A, I have two questions which you could probably answer together. So the question is like in this context of the digital advancements happening today. So where do you think like we are as India and where is the world? And connected to that, like how do we go to what the world is doing? Like how do we go forward and be in line with what the entire world is doing? So if you have to say it like in three simple steps, how can somebody start their journey with digital so we can also be in par with the world?
Okay. As I said, across the world, we can now see there are two patterns. One with maturity, and another of momentum. So in many developed regions like Europe, Singapore, and Middle East, in different regions, digital construction has become a norm, and it is not an expectation now. So the governments, they have made digital delivery mandatory for public projects, and that level of maturity came from a decade of consistent policy and training and collaboration between industry and the government. So now when we look at India, I would call this as as an acceleration phase. Like over a few years, over the past few years, the digital adoption has moved like beyond like projects, large scale projects, into state level infrastructures, national pipelines, and the private developments, and even small sized firms, they try to adopt. So like as I earlier discussed, like the platforms like Gati Shakti, smart city missions, they are already proving that that is the integrated data across disciplines or the departments, they are actually doing good. So where we are today is that India construction landscape, they match the global practices, but with its own flavor. India has its own flavor with a great speed and a purpose for it. And in terms of simple steps of how to being digital, what are simple steps? The first is that assess your need for automation. Then you take a pilot, uh, do a pilot study of that use, and then you revisit your technology periodically in order to keep on developing that, because the technology changes faster than our habits. So it is very much important for us to grow with it, one small step at a time, and it gives us a very good confidence to build on it.
Okay. Thanks, Simon. So we have one more question. The question is, in an industry where every professional is legally required to stamp and defend their own isolated work, who is ultimately liable for a mistake discovered in a truly collaborative and shared world?
Of course, these are very important questions that that should be actually considered on any contracts. And now the way of working, like say for example, integrated project delivery, wherein all stakeholders come together and they agree early during the project phase. They come during the planning phase, and then design phase. They say that these are our deliverables and this is how our working methodologies are, and each stakeholder will understand and know when actually should be the delivery, when their part should be played during the phase of the project life cycle. And also they agree on the financials parts, like the client as well as whoever is delivering, the stakeholders, they have equal risk and reward systems between them. It is equally split, and therefore it is not about nothing is lost by one person and nothing is gained by another person. So it is equally contributed, so it is very much transparent in these kinds of systems. So the main principle is that the procurement methodology that we follow should align with these kinds of collaborative practices.
Great. So we have two more questions. So I'm just clubbing both the questions. So the question is like, at what precise point does the information in building information modeling actually becomes more valuable than the model itself? And how do you prove it? So there is another question which asks like, how will we justify the ROI? So I think how do you prove it and how do you justify ROI probably means the same. So you can
So
kind of
one
answer.
is, as I said, the information is very much key when we talk about BIM. And this information comes from geometry, non-geometry, as well as the documents. So right now, so when you're talking about as in a model itself has a geometry, and therefore that is an information for us. And that along with that geometry, they have we have colors, we have materials, we have manufacturer data, and those are all again the data that we need to have to process that. So we cannot split our information with data, and therefore the information is making a meaning. For example, 300 is just a data, but when we say the wall thickness is 300 that makes an information and a valid information to process us further, even while using AI technology that will help us. What I would say is that the key here is for us to have a logical understanding, one. Second, to have a valid information, and that is where the BIM or the BIM models they come into play to give us proper models. If not, even when you use AI technology, that hallucinates more. So it needs the core memory to in order to process them, and we are feeding that AI with proper data in that. And I think in this context, even though there are multiple ROIs, people bring in the ROIs in terms of organizational, in terms of project level, and in terms of use case level. So the measurements are at different levels, but it is already proven that the time, cost, all these have direct impact, and that is one of the other reasons why the national level worldwide, people are trying to bring that as a process inside the government, inside projects, and inside organizations. And though there are multiple ways of measuring the ROI, I think it is always important for us to understand that there's always a scope where you can actually extend our way of thinking beyond a structured way of understanding what is an ROI.
Great. So thanks, Simon. I think we have answered almost all the questions. So, and we are like 5 minutes more into closing the session. So let me quickly wrap up and do the honor of thanking you. So before I just wrap up the session, it's pretty evident from our discussion with you, Mr. Simon, that we have a lot of good stuff happening with IT, and construction industry needs to be really fast and look at it, ensure what fits into our requirement and adopt it in a timely manner. The second thing is that the technology is evolving very, very fast. So we have to be really sure that we kind of give a try to every possible technology from every other industry and see how we can adopt it into our own way. And lastly, that the construction tech is all about collection, organization, and management of data, so that we have enough data to plan, execute, construct, and maintain, and even demolish the building through the project life cycle. So with all this, I would like to thank Dr. Simon for the insightful session that he has given over the last 30-40 minutes. And thank you, Dr. Simon.
Yeah, thank you very much, Arun, for hosting. And